This video is on applying Newton's second law of motion. Question number 1. A 14 kilogram mass is at rest on a horizontal surface. Part A, draw a free body diagram. Remember, step 1 is circle the object. Step 2 is label the forces. Step 3 is put an x and y axis. And step 4 is to use the equation, sigma F equals ma. So the only forces we have is the force of gravity and the normal force. Force of gravity always points from the center of the object. The normal force always points 90 degrees from the surface. Part B, what is the force of gravity acting on the object? So for part B, I used sigma F sub y equals ma sub y. I'm only looking at the forces on the y-axis. So we have plus force of normal minus force of gravity equals ma sub y. A sub y is 0. So force normal equals force of gravity. Force of gravity is mg. Part C, what is the normal force acting on the object? Well, from part B, force normal equals force gravity, which is mg. Question 2. Ishmael pushes a 16 kilogram block to the left on a rough horizontal surface with a force of 70 newtons. The block does not move. Part A, draw a free body diagram. Remember, step 1, circle the object. Step 2, label the forces. Step 3, put an x and y axis. Step 4, use the equation, sigma F equals ma. So I circle the object, label the forces, put an x and y axis. Remember, force of gravity always points from the center of the object. Force normal is always from the surface of the from the surface 90 degrees from the surface. Force of push is always from the contact location, and force of friction is between the two surfaces. Part B, what is the force of gravity acting on the object? Remember, sigma F sub y equals ma sub y. The only forces we have on the y-axis is plus force of normal pointing up, minus force of gravity pointing down equals ma sub y. A sub y is 0. So force normal equals force gravity equals mg. Part C, what is the normal force acting on the object? From part B, we know force normal equals force gravity. Part D, what is the force of friction exerted on the block? Let's take a look at these horizontal forces. I chose positive x to be to the left. So I have plus force of push minus force of friction equals ma sub x. A sub x is 0. So force of push equals force of friction, which is 70 newtons. Why is it 70 newtons? Because it was given to us. Part E, what is the coefficient of static friction? Force of friction equals mu force normal. Solve for mu. Question 3. Isaac pushes a 18 kilogram block to the left on a smooth horizontal surface with a force of 70 newtons. Part A, draw a free body diagram. So circle the object, label the forces, put an x and y axis, which I did not. Positive x is to the right, negative x is to the left. Positive y is up, negative y is down. Part B, what is the force of gravity acting on the object? Let's take a look at the forces in the vertical direction. Plus force of normal minus force of gravity is ma sub y. A sub y is 0. Force normal equals force of gravity, which is mg. Part C, what is the normal force acting on the object? Force normal equals force of gravity from part B. Part D, what is the horizontal acceleration of the block? Sigma f sub x equals ma sub x, positive x is to the left. So force of push equals ma sub x. Solve for a sub x. Force of push is given to us. Part E, what is the vertical acceleration of the block? It's 0 because it's not jumping up or down. Question 4. Jacob pushes a 20 kilogram block to the left on a rough horizontal surface with a force of 70 newtons. The block moves at a constant speed of 2 meters per second. Part A, draw a free body diagram. Remember, circle the object, label the forces, put an x and y axis, and use the equation sigma f equals ma. Part B, what is the force of gravity acting on the object? Take a look at only the vertical forces for part B. Plus force of normal up minus force of gravity down equals ma sub y. This object is not jumping up or down, so a sub y is 0. So force normal equals force of gravity equals mg. Part C, what is the normal force acting on the object? We could just take a look at part B. Part D, what is the horizontal acceleration of the block? Well, it says it's moving at a constant speed of 2 meters per second. So a sub x is 0. Part E, what is the vertical acceleration of the block? The block is not jumping up and down, so a sub y is 0. Part F, what is the force of friction exerted on the block? It's moving at a constant speed, so a sub x is 0. So force of friction equals force of push, which is 70 newtons. Finally, part G, what is the coefficient of friction mu between the block and the surface? Force of friction equals mu Fn. Solve for mu. Part E, Question 5. Adam pushes a block with a mass of 24 kilograms to the right on a rough horizontal surface with a coefficient of kinetic friction of 0.3. The block moves with a constant acceleration of 2. Part A, draw a free body diagram. Remember, step 1, circle the object. Step 2, put an x and y axis. Step 2, label the forces. Step 3, put an x and y axis. Step 4, use the equation F equals ma. So I'm going to say positive x is to the right and positive y is up. Part B, what is the force of gravity acting on the object? We know this object is not jumping up or down. So a sub y is 0. So plus force normal up minus force of gravity down equals ma sub y equals 0 newtons. Since a sub y is 0, force normal equals force of gravity equals mg. Part C, what is the normal force acting on the object? Force normal equals force of gravity. Part D, what is the force of friction exerted on the block? Force of friction equals mu Fn. Force normal is mg. Part E, what is the force of push given to the block? So sigma F equals ma sub x. Sigma F is equal to force of push minus force of friction equals a sub x. Let's solve for force of push. And then plug in everything we know to get 190 newtons. Question 6. Joseph is pulling a 65 kilogram block with a force of 800 newtons at an angle of 45 degrees north of east above the horizontal of a rough horizontal surface. The coefficient of friction between the block and the surface is mu equals 0.3. So part A, draw a free body diagram. Remember, step 1 is circle the object, step 2 is label the forces, step 3 is put an x and y axis, step 4 is use the equation, sigma F equals ma. Part B, what is the vertical acceleration of the block? It's 0 because the block is not jumping up and down. Part C, what is the normal force acting on the block? We're going to use the equation sigma F sub y equals ma sub y. A sub y is 0 since it's not jumping up and down. What forces do we have? Plus force of normal, plus force of pull sine of theta, minus force of gravity. So we have two forces pointing up and one force pointing down. So this is new, but we haven't seen in previous problems in this video. So solve for force normal. It's about 72 newtons. Part D, what is a horizontal acceleration of the block? So part C, we used sigma F equals ma for the y-axis. Now we're going to use it for the x-axis. And let's just solve for a sub x. Plug in everything we know to get 6.25. Question number 7. An 80-kilogram man is standing on a scale in an elevator. Determine the reading on the scale when A, the elevator is at rest. So when the elevator is at rest, sigma F sub y equals ma sub y, plus force of normal minus force of gravity equals ma sub y. A sub y is 0, so plus force normal minus force of gravity is 0. Force normal equals force of gravity equals mg, which is about 785 newtons. Let's read 7b. An 80-kilogram man is standing on a scale in an elevator. Determine the reading on the scale when the elevator is moving up with a constant speed of 2 meters per second. If the elevator is moving up at a constant speed of 2 meters per second, a sub y is 0. So parts A and B have the same procedure, same solution. Part C, the elevator is moving down with a constant speed of 2 meters per second. If it's moving down with a constant speed, that means acceleration is 0. So we have the same procedure. Plus force of normal minus force of gravity equals 0 newtons. Things get different with part 7D. The elevator moves up with a constant acceleration of 2. So acceleration is plus 2. We're going to plug in that into this equation here. So plus force normal equals this equation, m times a sub y plus g. We get 945 newtons. So compare part A with part D. When we're at rest, the scale reads a force of 785 newtons. When we're moving up, the scale reads a number that's greater than 785 newtons. You could feel your heart go down in an elevator when you're moving upwards, accelerating upwards. Part E, what if the elevator moves downwards with a constant acceleration of 2? If the elevator moves downwards, that means acceleration is going to be negative 2. Why is it negative 2? It's just the way I drew the picture. I said positive y is up. So we're going to plug in a negative 2 into this equation here. And we get 625 newtons. So when we're at rest, we feel the scale feels a force of 785 newtons. When we accelerate up, the reading on the scale is greater than 785. And when the scale accelerates, when the elevator accelerates down, the scale reads a force of less than 785. Question 8. A block with a mass of 15 kilograms is on a rough horizontal surface. So that's the one on the bottom here. There is a string pulling it to the right with a force of pull at a constant speed. Above M2 there is a block with the mass M1 of 12 kilograms. So that's the object on top. there is a string attached to the left of M1 which is attached to a wall which has a force of tension Ft. The coefficient of friction between M1 and M2 is 0.25 and the coefficient of friction between M2 and the surface is 0.35. Part A, draw a free body diagram. So for mass M1, I didn't circle the object just because it's going to get too complicated. We got force normal 1 pointing up, force gravity 1 pointing down, force of tension to the left, force of friction between mass 1 and 2 to the right. Now, for M2, look at the image on the right. We got force normal 2 up, force normal 1 down, and force gravity 2 down. We got force of friction between object 1 and 2 to the left, force of friction between object 2 and the surface to the left, force of tension to the right. Something interesting. Force normal 1 points up for M1, force normal 1 points down for M2. Force of friction between mass 1 and 2 points to the right for M1. It points to the left for M2. So the same exact force points in opposite directions for both objects. Part B, determine the force of tension Ft. Part C, determine the pulling force Fp. So you could say here we have 4 equations. We're going to use sigma F equals ma for the x-axis and the y-axis for M1, and sigma F equals ma for the x-axis and the y-axis for M2. So take a look at what I did here for M1, for the y-axis. Plus force normal 1 minus Fg1 equals 0 newtons. Take a look at what I did here for sigma F equals ma on the horizontal axis for object 1. Plus force of friction between mass 1 and 2 minus force of tension is 0 newtons, because A sub x is 0. Look at mass 2. Sigma F sub y2 equals m2 A sub y2. We know A sub y2 is 0 because this object is not jumping up and down. So we got these 3 forces equal 0 newtons. And we could solve for F and 2 here. Here we've solved for Fn1 and Fg1. Here we solve for Ft over here on the bottom left. So take a look at this bottom right. Sigma F sub x2 equals m2 A sub x2. So this is the horizontal forces on mass 2. We know A sub x2 is equal to 0 because we were told that it moves with a constant speed. Constant speed here. So here I was able to solve for plus force of pull. So part C wants us to solve for force of pull. Bam, it's here. Part B wants us to solve for force of tension. It's here. Question 9. A 12 kilogram block is held in the air by 2 strings attached to the wall. The first string makes an angle of theta 1 equals 60 degrees north of west. The second string makes an angle of 45 degrees north of east. Part A, draw a free body diagram. Remember guys, circle the object, label the forces, put an x and y axis, and use the equation, F equals ma. Part B, find the force of tension on each string. So, if going east is 0 degrees, and going clockwise is plus theta, counterclockwise, then force tension 2 is going to be 60 degrees. Force tension 2 is going to be 45 degrees, and force tension 1 is going to be 90 plus 30 degrees, 120 degrees. So, sigma F sub x equals ma sub x. This block is not moving, a sub x is 0. So we have these three forces equaling 0 newtons. We know the cosine of 270 is equal to 0. You could put that in your calculator. So we end up only getting two forces acting horizontally. Force tension 1 and force tension 2. So we have this relationship here. Force tension 1 equals root 2 force tension 2. Sigma F sub y equals ma sub y. A sub y is 0 because this block is not moving up and down. We have these three forces equaling 0 newtons. So now we have this relationship here. So, what do? We could substitute this yellow equation into the green equation. So ft1 equals root 2 ft2, we could put that here. And then we could solve for ft2. And once you find ft2, we could substitute it back to find ft1. Question 10. A block with mass 15 kilograms is at rest on the bottom of an incline with theta equal 25 degrees, which is 35 meters long. The coefficient of friction between the block and the surface is mu equals 0.450. The man pushes the block up parallel to the incline with a force of 155 newtons. Part A, draw a free body diagram. So circle the object, label the forces, put an x and y axis, and use the equation. So take a look at my x and y axis. My x axis is parallel to the slope, and my y axis is 90 degrees from the slope. My x axis is not westward, and my y axis is not northward. Okay. I did this to minimize sines and cosines. So Fn is purely in the plus y direction. Force of push is purely in the positive x direction. Force of friction is purely in the minus x direction. And force of gravity is a bit in the x direction and a bit in the y direction. Okay. You can see there's this right triangle here making up the force of gravity. Part B, what is the acceleration of the block? So sigma F sub y equals ma sub y. A sub y is 0 because the block is not jumping up and down. Take a look at the y-axis. It's 90 degrees from the surface. This block is being pushed parallel to the surface. So plus force normal minus Fg cosine theta. This part here, force of gravity on the y-axis, it's the cosine part if this blue thing is theta. So force normal minus Fg cosine of theta is 0. Solve for force normal. Now we're going to use sigma F sub x equals ma sub x. So the acceleration of the block part B wants us to find a sub x. So solve for a sub x. What forces do we have on the x-axis? Plus force of push, minus force of friction, minus force of gravity, sine theta. So you could see this x part is the sine of theta. So that's how we get this equation. Solve for a sub x. Plug in the values to obtain acceleration is 2.19 meters over second squared. What will be the final speed of the block when it reaches the top of the incline? Remember, this is a Suvat equation. How long will it take for the block to reach the top of the incline? Remember, this is a Suvat equation. Question 11. A block with mass 0.65 kilograms is initially at rest in the middle of an incline with theta equals with theta equal 25 degrees, which is 40 meters long. The coefficient of friction between the block and the surface is 0.45. A man pushes the block down parallel to the incline with a force of 60 newtons. The block accelerates downward at a constant rate. Let the acceleration from gravity be g equal 9.81 meters over second squared down. Part A, draw a free body diagram. Circle the object, label the forces, put an x and y axis, use the equation F equals ma. Notice x is parallel to the incline, y is 90 degrees to the incline. Part B, what is the magnitude of the acceleration of the block? So, sigma f sub y equals ma sub y. A sub y is 0 because this block is not jumping up and down. What forces do we have on the y-axis? We have force normal minus fg cosine theta. Why do we have fg cosine theta? Because you could look here. If this is theta here in red, then the vertical part is this y, so that's cosine of theta. Solve for force normal. We get 578 newtons. Now sigma f sub x equals ma sub x. What forces do we have in the x-axis, horizontal axis? It's force of push minus force of friction plus force of gravity sine theta. That's how we get this equation. Solve for a sub x. We know force of friction is mu force normal. Part C, what will be the final speed of the block when it reaches the bottom of the incline? This is a Suvat equation. Part D, how long will it take for the block to reach the bottom of the incline? That's a Suvat equation. Question 12, a block of mass m1 is on a frictionless horizontal surface and is pushed to the right. There is another block of mass m2 which is to the right of block m1 and above the surface. m1 is pushed and accelerated to the right, so m2 does not slide down. So m1 is the larger block, m2 is a smaller block. You push m1 to the right, and m2 actually doesn't slide down. So label the forces on m1 and m2. So circle the object, label the forces. So for the first image on the left, the bottom left, those are the forces on m1. And then and for m2, you circle the object, you label the forces. Part B, determine an equation for the minimum pushing force in which m2 does not slide down. So you could say we have four equations, right? Sigma f equals ma for the x-axis for both masses, and sigma f equals ma for the y-axis for both masses. So for m1, we get this for the horizontal axis. For m1, we get this for the vertical axis. For m2, we get this for the x-axis, and we get this for the y-axis. So for the whole system, sigma f sub x equals m1 plus m2 times a sub x is equal to this. So this is the force needed to push the object, so m2 doesn't slide down. Because they want us to solve for the minimum pushing force, which we have here. Okay. Use a Pencil and ruler. Define free fall. Draw a displacement versus time graph, a distance versus time graph, and a velocity versus time graph, a speed versus time graph, and an acceleration versus time graph for an object dropped from rest in free fall. So this is the meaning of free fall. An object is in the air. The only force acting on it is a force of gravity, no air friction. And the object could be moving in any direction. So displacement versus time on the y-axis looks like this. Velocity versus time looks like this when it's dropped from rest. Acceleration versus time looks like this. Distance versus time looks like this because distance is always positive. Speed versus time looks like this because speed is always positive. Now velocity versus time looks like this because we know velocity is pointing upwards, positive velocity. So this means velocity is negative when it's dropped from a surface. Displacement versus time looks like this because the slope is negative as time increases, meaning the velocity is negative, because the slope of displacement versus time gives us velocity. And acceleration here is negative, meaning it points down. Acceleration points down, and positive y is up. So they're in opposite directions, so that's why it's negative.